solve a system of equations by substitution method. Here we have two linear equations in x and y, and we're going to solve it using the 5 steps listed in your text. First step is to solve one equation for one variable. We're going to do that by subtracting 3x from both sides, and we're going to choose this equation to work with it because we're going to solve for y, and y already has a coefficient of 1, so it's easy to use that one. Okay, so subtract 3x from both sides, and we quickly get an equation with y isolated on the left-hand side. So now we know that y equals negative 3x minus 3. We can take this whole equation, this whole term, and plug it in for y in the second equation. And we're going to do that. 2x plus 5. This is the new value of y, the alternative value of y. And now we're set up with an equation in one variable. Now we can solve it. The y's have disappeared. We've substituted in a replacement for y. So we need to distribute here. 5 times negative 3x is negative 15x. 5 times negative 3 is negative 15. This should be a plus sign. Now we combine similar terms. Negative 13x minus 15 equals 11. We want to isolate the x on one side of the equation. So we're going to get the 15 on the other side of the equation by adding it to both sides of the equation. Okay, so we have negative 13x equals 26. 26 just happens to be a multiple of 13. So if we divide both sides by negative 13, we get x equals negative 2. We now know x. Well, we have now found the value of x, or we think so, unless we've made a computational error, and x is negative 2. So we're at the plug-in step, and we take the first equation, which is 3x plus y equals negative 3, and we plug in this negative 2 for x. So 3 times negative 2 plus y equals negative 3. Our goal is to this time solve for y. We already know the x. We need to find the y also. So 3 times negative 2 is negative 6. We add 6 to both sides of the equation to isolate the y variable. And negative 3 plus 6 makes 3. So if we've done everything correctly, we've solved for y in terms of x, substituted in, solved for x, taking this numerical value for x and plugged it into the first equation, and then solved for y. We now think that the solution to this system is negative 2, negative 3. Well, we need to check So let's put our potential solution, which we're fairly confident of. This is the ordered pair xy. We think that the solution for the two equations is x is -2 and y is +3. So we're going to, again, plug these values in each of the equation, and if it works for each of the equations, we're fairly certain that we have a solution. So the x is -2 and the y is 3. Now let's see if this works. 6 plus, the -2. 3 times -2, because x is -2, makes -6. We put the 3 instead of the y. -6 plus 3 makes -3. Okay, so it checks in the first equation. Now take the -2 and -3 and put it in the second equation. The -2 is the x, the 3 is the y. So 2 times -2 is -4. 5 times 3 is 15. Okay, I hope it works. Yes, 11 equals 11, and the second equation works too. Okay, so our conclusion, following this four-step method, in which the last step is to check our results, is these equations match intercept when x equals -2 and y equals +3.